All right, this is the hint for the PSAT NMSQT number 12 problem from fall 2016 on the no calculators section. They've given us a rather complex equation with rational expressions on both sides, which means fractions on both sides. So it gives us the equation. It says if this is true and x does not equal 35/4 or 5, which is the value of 5x squared. This little piece right here isn't something you need to worry terribly about. Basically what they're doing here is making sure that the denominators aren't 0 because you can't divide by 0. So this part right here, don't even worry about that. If you happen to get an answer that was one of these, you'd have to throw it out, but they're not going to do that to us on this problem, so we're just going to not worry about that. So it's weird because it's asking us for the value of 5x squared instead of just x, but we're going to solve like we're looking for x. This is a giant proportion, really, so we're going to cross multiply. I'm going to take these two and multiply them. So it'd be x minus 30 times x minus 5, and that's equal to these two expressions multiplied, so x times 4x minus 35. I've made this example a little bit more complicated than what was actually on the test, but it'll work and you'll get the idea. So on the left side, I'm going to distribute everything out. X times x is x squared. X times negative 5 is negative 5x. Negative 30 times x is negative 30x. Negative 30 times negative 5 is positive 150. We can clean up this side by combining like terms. So x squared minus 35x plus 150 on that side. Then on the other side, we're just doing a simple distribution. X times 4x is 4x squared. X times negative 35 is negative 35x. So I've got quadratic expressions on both sides. We typically want to get all of that on one side of the equation. And we typically want this x squared term to be positive. So what I'm going to do is I'm going to subtract x squared from both sides to make this 3x squared. And I'm going to add 35x to both sides, which is actually going to drop out. That's kind of nice. And then I'm going to subtract 150 over here, so I'm going to have minus 150. And I made the left-hand side equal 0. You could make the right-hand side equal 0, but I was trying to keep this leading coefficient in front of the x squared positive, and my brain thought that this was an easier way. So it's nice that we don't have that middle term, because that means we could factor this a little differently. I'm going to start by taking a 3 out of both terms. I'm sorry, I'm not going to take a 3 out of both terms. What I'm going to do is I'm going to add 150 to both sides. So 150 equals 3x squared. So instead of factoring, I'm just going to rearrange the equation. Sorry for any confusion on that. And then I will divide by 3, and I get 50 equals x squared. Now if I wanted x, I'd have to go ahead and square root and go through all that. But remember, they're asking for 5x squared. So if x squared equals 50, then 5x squared would be 5 times 50, which is 250, which means my solution would be answer B. So if you know a little bit about solving equations and solving just basic quadratics, that one is not too bad.